This is our first content quiz, the experimental design one, and I'm just going to go through how I would have solved it. Purpose was to find the percentage of iron filings in a mixture of sand and iron filings. And an iron filing is a tiny piece of iron about the same size as a piece of sand. Possible materials are a mixture of sand and iron filings, a strong magnet, paper, scale, water, and matches. So again, I'm going to go down and I'm going to look at my calculated values first. So I'm going to scroll down here. I know for sure that I'm going to need to solve for the percentage. That's one thing. I'm definitely going to need to find the percentage of iron. And my unit is percentage. I have to solve for that. I know for sure that's a calculation. That's not something I can measure. Now, the two things that I need to know to do that are the mass of the iron and the mass of the whole thing. Now, in my brain, when I'm thinking about this, they're together to start with, and then the next thing I see is a magnet, so I know that iron is magnetic. So I can picture in my mind that I'm going to do something with putting the magnet over the sand and iron. It's going to lift them all out, and then I'm going to have just iron on the magnet. Now, I know whether I'm weighing the magnet and the iron together, maybe I'm weighing the iron on a piece of paper, but I can't just scrape my iron onto the scale. So therefore, my mass of iron is not going to be a measurement. It's also going to be a calculation. And that was a big mistake that people made, that they thought they were going to be able to measure things that they couldn't. Same thing is going to apply for the sand and mixture. This mixture of sand and iron filings, I can't just dump that on the scale, whether it's on a piece of paper, maybe it's in a beaker, maybe it's in a dish, like we don't know. But I'm going to have to also calculate that out as well. And that's, again, the common mistake that was made of iron sand mixture. Okay. Now, maybe I did this with multiple trials. Maybe I didn't. It doesn't really say that, oops, that I need to. But sure, you could have a couple of rows here so that we could do 3 trials and kind of get a good average off of that. If we did, then maybe we have something down here at the bottom that says like average percent, average mass. That wasn't really a requirement, but if you did, you definitely could have. Okay. Now, that means that in order to get this, I know that I need this and this. Okay, let's talk about this one first. Again, that can't be right on the scale. It's going to be inside of something. So maybe it is inside of a beaker to start. Mass of iron, sand mixture. And then this data table, this experimental data table should say exactly what's being measured in the lab. So, and beaker. Now again, you could have said that that's, you could have said that that's on top of a piece of paper. You could have said that that's in some kind of other container, but that's what we would have measured when we were back there on the scale. Okay. To get this one, we would have needed to know maybe it's on a piece of paper, maybe it's on the magnet, whatever it is. So mass of iron and something. So it could have been magnet, paper, etc. Now I got both of those. Now if I want to get rid of this, then I need to know the weight of that. So I'm going to go back in here. I'll put mass of just the beaker. That way I can subtract it out later. Same thing for here for this one. Mass of just the magnet, paper, whatever. I can do that. This could have been simplified a little bit here, but basically I know that I'm going to take this, subtract out this to get this. And then I'm going to take this, I'm going to take this and subtract out this to get this. And I'm going to take this and this and subtract them to get this. And then I'm going to take this, and divide them to get this? And that's exactly what question number 4 is asking, but I'll do that in a second. So, procedure. Let's make this nice and easy. Some bullet points here. So, measure mass of empty beaker. Measure mass, you could say, I guess, pour some iron sand mixture into beaker and measure the mass. Use let's say we did with magnet. So we gotta measure the measure mass of magnet. Use magnet to separate. I always misspell separate. Separate iron from sand iron mixture. And then measure mass of magnet and iron filings. Now, you could have done a lot of different things, but this procedure would get me this data, and this data would get me these calculations. That's kind of our overall idea. Okay? Now, again, we didn't say that you had to do it multiple times. You could have said repeat 2 more times. For this case, it didn't even matter that you get exactly the same amount on there. Lots of different variables that could have also been in there. Now, that means we didn't need the scale, or excuse me, we didn't need the water, we didn't need the matches. Those were just in there. They threw some people off. There are always lots of possible materials. So now let's go down here. I'll complete how you would have done the calculations based off of these things. I would have done mass of mixture and beaker minus mass of beaker equals mass of mixture. And then I would have done mass of magnet and iron minus the mass of the magnet equals the mass of the iron. And then I would have done the mass of the iron divided by the mass of the mixture times 100, and that would have gotten me my percentage. Now, some people did some stuff with finding the percent of sand. That's fine. Basically, if you didn't have enough information to complete the purpose to find these percentage calculations, then we didn't get it. Okay? If you had said down to the errors and mistakes, you could have said impossible to know that it was in there. Someone else gave it to us. That makes it an error. If you say that you should have got a new batch, could have done that. Maybe you can see the other metal, maybe it's a different color, then that would have made a mistake. Either one would have gave us an okay answer. Okay, measured mass. It depends on how people thought about this. If we just took it out, so we saw it was there, took it out, and did experiment. That would mean that the mass of the mixture was less. Mass of iron less. Maybe you measured the mixture, then took it out. Other thing, that means the mass of mixture was the same, but the mass of the iron was less. Now down here, that would affect everything. So those are, again, kind of two possible answers. Most people got this right, but if it wasn't clear which one you were doing, that kind of did mess you up. Now here, how would this affect your calculated percentage? If there's less iron, then there's probably less percentage. That's what most people said. But it was possible, depending on how you kind of said this, that if the whole mixture was less and the mass of the iron was less, then it may not have made a difference overall, because you did kind of take it out. But that was probably the most common answer that I was looking for. So that wraps up our thing for the experimental design quiz. Please come and see me if you have any more questions.